Let's study on the relationship between derivatives, tangent lines, and local linearity. Based on the definition of the derivative, we know the derivative represents the slope of tangent line at every point across the domain. If the derivative positive, the curve is increasing. If negative, decreasing. If zero, that means at that point the tangent line is horizontal. The point is called critical point. It is a potential maximum, minimum point, or point of inflection. Tangent lines, they don't just touch the curve. They exactly and perfectly trace the curve, providing the best linear approximation to the function at every point across the domain. That means in a small neighborhood around x equals a, tangent line can be used to approximate the corresponding portion of the curve. If we zoom in really close on a smooth curve, the small portion of the curve from the point x equals a to a neighborhood point can be treated as a line, as long as the distance is very tiny, h approaches 0. So simple line can be used to estimate complicated curved behavior in small region. The keyword here is smooth. We know derivative does not exist at a point with sharp turn, or does not exist at a jumping point. Let's use Python to visualize how tangent lines follow the curve. First, import the packages we need. Set up the plotting canvas. Here I constructed a polynomial function in factored form because I want to control the number of turning points and the shape of the graph. Also, I don't want to remove the parentheses, so I use the central difference method to get the numerical derivative. Here I want to pause the horizontal tangent lines at critical points. The functions plot, pause, and time sleep don't work in Notebook. So we just set up how many pause frames we want. And the function of generating the frames and animation. Here 0.1 is not really close to 0. But just to avoid the floating point precision issues. If the value were too small, like suppose 0.001 really close to 0, then the horizontal tangent lines might be missed. Let's run the code. The different colors mean the positive or negative or zero slope. You see the tangent lines follow or trace the curve. Next, let's use Python to visualize local linearity with tangent lines. Here we import this function from this module. This module is in matplotlib because I want to have a smaller plot inside the bigger one. So this is for the overall view. The bigger one is we zoom in the particular small region around this point. Set up a small plot for overall view and initialization. Then this is the animation function with the speed. So let's pause here. Here I choose 2.5 as the point of interest. You can choose other points on the graph. So we zoom in, you see the very tiny neighborhood around this point. The portion of the curve can be estimated by the tangent line segment. So that means we can break the complicated curve into many tiny simple line segments. That's the foundation for applications in physics, engineering, and machine learning.